Hello, Proximity Math back here, and I'm going to go over the 2020 AIMC 10A number 21. So it says there exists a unique, strictly increasing sequence of non-negative integers, a1 less than a2, and so on until a of k. So this has k terms, by the way, since it's a sequence with indices 1 through k. And we have this equation, and it's asking what's k. That just means what's the number of terms in the sequence. And it says there exists a sequence. That means, basically, if you read the question properly, it's asking if you expand the expression on the left into this sum of powers of 2, then what's the number of terms in that sequence? Because these are just, the sequence elements are just mapped on to the powers of 2 here. And there's even a of k. That means there would be k terms in here, and we have to find the number of terms. Okay, now worry about this. So we even need 2 factorizations. Now, if we have a sum of odd powers, minus 1, that is going to equal x minus 1 times x to the 16th plus x to the 15th until 1. And similarly to the real factorization, if you have a plus 1, that's going to have a factor of x plus 1. This is a bit of advanced factorization. Just remember this if you don't know it already. This only works for odd powers, by the way. For even powers, the difference might even be all this works. So it would be something, in this case, it would be 1 less power, and then minus x to the 15th, plus x to the 14th, and until x squared minus x plus 1. And note that this has a factor of x plus 1. Okay, so now, how would we apply a factorization something like this? Like this. So if we want this to be any whole number at all, that means this would have to be a factor of this, and we can substitute that. Well, not substitute, you have to find this first. The problem's not going to give it to you. So we can make this x so that we can have a factorization at all. And to make everything seem clearer, so this is x to the 17th plus 1 over x plus 1. And x is not negative 1 in this case, so we can divide that out. Basically, look for a factorization like this. And that's how you find this. And that's going to be x to the 16 minus x to the 15th. Now, for this sequence, we can't just substitute this in because it has negative signs. It's an alternating sequence, and we only need plus signs in here. So how do you convert to plus signs only? So now, x to the 15th, sorry, these are negative terms, and what if we, well, first of all, focus on x to the 16th. If we substitute in x's actual value, and also use something that you must have heard of before, that x to the 16th, so first we'll substitute this x to the 16 times 17, sorry, 2 to the 16 times 17, and that's equal to 2 to the 16 times 17 minus 1, and the sum of all the powers, and then it's going to be plus 16, plus 8, plus 4, plus 2, and there's actually going to be another plus 2 at the end. And by the way, this works because you can cascade the 2 and the 2 to the 4, and so on, like the game 2048. It's going to go into this. Actually, just as geometric sum backwards, but you should know it for powers of 2. Okay, so using that we're going to get, it's going to be this huge sum of powers going down to plus 2. And actually, you should know this right away, but you have a minus. And this is also going to be a sum of powers, but it's going to start later because it's a smaller power of x. And these would cancel out. So note that this would start at x to the 16 times 17 minus 1, and then a sum of powers. And this would start at 2 to the 15 times 17 minus 1, and a sum of powers. The 17 minus 15 minus 1 times 15 minus 1 is going to be cancelled out with expansion of x to the 16th. That means it would just be, this is the last non-cancel term. And if you count these, it would be 17 of them. So there's 17 of these. Now, note that these are all the even numbers, and we're pairing of it's pairings of 2. So in here, there's going to be 8 pairings. So there's going to be 17 times 8 total elements. So don't forget the 1, because that's actually 2 to the 0, and it's non-negative integers. So it's going to be 17 times 8 plus 1 in total, and 17 times 8 is 136, plus the 1 is 137. Thanks for watching Proximity Math, and see you next time.